When it comes to running a large database, performance is a key consideration. But no one can predict and prescribe universal solutions. Every scenario differs, and your mileage will vary, and vary significantly from another. Rather than try and prescribe recipes then, let's focus on key characteristics of MapReduce and highlight how it interacts with your Mongo installation. When you run MapReduce and output inline, MapReduce will not create a collection. This means you can run it on secondaries. If you use any other option, a collection is used, so you have to run the job on a primary. Mongo stores documents in BSON format, not JSON. When map produces a value, it is a JSON object. By default, Mongo would then convert that JSON to BSON if it wanted to store it in a collection, and store it in an intermediate document until the reduce is called with the emitted values. There is an option to tell Mongo to keep the intermediate results in JSON so that conversion to and from BSON is not necessary. This might be a performance boost, but your mileage may vary. Try, measure, and see if it makes sense in your case. When you scale out and shard your collection, you can also tell MapReduce to store the results in a sharded collection. You must, of course, have enabled sharding. When you use this option, the ID field is the shard key, and you can't choose another. MapReduce jobs can take a long time to finish. Just like aggregate, you can pre-filter your collection and only run MapReduce on a subset of the documents in a collection. We've seen that with a query on author first name before. This, in combo with incremental MapReduce, gives you more control over the resource usage during the job. If you find that running MapReduce on your whole collection is too taxing, find a way to run incremental MapReduce on a batch of documents at a time, and then run it multiple times. Looking beyond the characteristics of aggregate and MapReduce, there are data modeling techniques that can help your performance and solve some aggregation needs. Let's say you're adding new documents. Each document has a category. You can, as you've seen, run aggregation to get counts by category. Another option is to aggregate on write. You create another document with just the category as the ID and a count as a value. Then each time you add or remove a document for that category, you update the counts document using an update command and increment or decrement that number. This way, you always have a running count fairly up to date, maintained by your application itself. You can audit and refresh this number periodically if its maintenance was not proper and avoid running and rerunning full aggregations over a large number of documents. When it comes to scalability and performance, there are no hard and fast prescriptions. You'd ultimately need to experiment, measure, and make changes to code where necessary.